Hello students, we are still on sum of a geometric progression. Sum of a geometric progression. We already said that whenever the relationship between successive terms is in form of a ratio, that is, we are talking of a geometric progression. If you look at this is what a geometric progression: 2, 4, 8, 2 times 2, 4, 4 times 2, 8, 4, 8 times 2 is what? 16. This is a geometric progression. Now, to look for the sum, we are looking at the sum of geometric progression. Now, if you have this, so the formula that will now be adding the number. So if this first term, we want to add the first two terms, that's 2 plus 4 will give us 6. First three terms of this sequence were 2 plus 4 plus 8, which will give us 14. Then first 4 times 2 plus 4 plus 8 plus 16, which will give us 30. So whenever we are given a geometric progression, to look for the sum, we can use this formula: sum of an n term of a geometric progression, a into bracket 1 minus r raised power n over 1 minus 1 r. You are going to use this formula when the value of r is less than 1, when the absolute value of r is less than 1. Now, we have another formula here: a into bracket r raised power n minus 1 over r minus 1. You use this one whenever the value of r is greater than 1. Use this one whenever the value of r is greater than 1. Then, if you are told to look for the sum to infinity, you are going to use a over 1 minus r. A over 1 minus r. Now, let us look at this example. The sum of the GP below. Find the sum of the GP below. You are given 2, 6, 18, 54. The number continues to get it to 1,458. But before we can look for the sum, like there are hidden numbers here that we don't know the value. We need to know the value for n here. How many terms are in this particular thing? So here the first term here is what? A, which is what? 2. Second term, the one at the back minus the one in front. The one at the back divided by the one in front. 6 divided by 2 will give us what? 3. 18 divided by 6 will give us 3. 54 divided by 18 will give us 3. So 3 is a common ratio. Then we are given that the nth term here is 1,458. So that means if the n term is 1,450, what will be the value for n? So the n time is equal to your common first term is 2 times 3 is the common ratio raised power n. We don't know the value of n, minus 1 is equal to 1,458. So you're having 2 times this is equal to this. So to be able to divide both sides by 2, so that we are left with 3 raised power n is equal to whatever you have here. So that means it's equal to 729. So 729 can still be written as 3 raised power 6. So 3 raised power n minus 1 is equal to 3 raised power 6. From here you can equate their powers. So when you equate their powers, you have n minus 1 is equal to 6. So this is minus 1 here. When it comes here, now turn to plus. So n is equal to 6 plus 1. 6 plus 1 is what? 7. So that means the number of terms here is what? 7. So that means by the time you complete this number 1, 2, 3, 4, the 5th, 6th numbers are missing till you now have the 7th number. So now, if this a number of terms is 7, the question said that you look for the sum of the GP. What is now the sum of the GP? So now because now look at it here, our first term here is what? 2. Our common ratio is 3. So since our value for the ratio here is greater, 3 is greater than 1. So 3 is greater than 1, you are going to use this formula. So since 3 is greater than 1, you will use this formula: a into bracket r raised power n minus 1 over r minus 1. So you are going to use this formula: a into bracket r raised power n minus 1 over r minus 1. So substitute the sum of the first 7 terms will now be is equal to a is 2 into bracket 3 raised to power n is 7 minus 1 over r is 3 minus 1. So that means 3 raised to power 7 give us 2187 minus 1. Subtract 1 for me to have 2186. Then times these two over 2. So when you divide 2 times this over 2, 2 cancel to the remaining what? 2186. So that means if you add those figures, that summation will be what? 2186. Now let's look at the second example. Given the GP below 30, 15, 7.5, 3 whole number 3 over 4 ... as far as 8 term, find the sum of the first 8 term. So here you are given that you should look for the sum of the first 8 term. So first of all, the first number here is what? 30. You are having the first term there to be 30. The common ratio will be the one at the back divided by the one in front. 15 divided by 30 will give us 1 over 2. Like when we say 7.5 divided by 15 will give us 1 over 2. So now you are told to look for the sum of the first 8 term. So the value for n here will be what? 8. So if you look at the common ratio here, r here is what? Less than 1. Since the value of r here is less than 1, you are going to use this formula: a into bracket 1 minus r raised to power n over 1 minus r. So you are going to use this formula. So when you use this formula, substitute. The value for your a is what? 30 into bracket 1 minus r is what? 1 over 2 raised to power n is 8 over 1 minus r is 1 over 2. So that means if you open the bracket, you're having 30 into bracket 1 minus, you're having 1 over 2 raised to power 8. If we expand this one, 1 raised to power 8, 2 raised to power 8. So this one will give us 1 over 2 raised to power 8. So everything divided by 1 minus 1 over 2 here will give us half. So that means you're having 30 into bracket 1 minus 1 over 2 raised to power 8 will give us 256. Then it will give us 256. Then everything, this is divided by 1 over 2. So if you look at this one will look like fraction. This same thing as saying, this is same thing as saying that this 1 over 1. So the LCM of this 1 and 256 here will be 256. 1 in 256 is 256. And this one give us 256 minus 256 in 256 is 1. 1 times this 1 will give us 1. So that means we are having 30 into bracket 256 minus 1 over 256 times 2. So that means we are having 30 times 256 minus 1 will give us 255 divided by 256 times 2. So when you are having 2 here 1, 2 in 256 is 128. 2 in 128 is 64. 2 in 30 is what? 15. So when you multiply 15 times 255 all over 64, when you multiply the two, you are going to get 15 times this one will 3,825 divided by 24. When you divide it by 24, you are going to get 59.765625. Let's look at another example. So the sum to infinity of a GP is 60. If the first term of the series is 12, find its second term. So first of all, you are given that the sum to infinity is what? This symbol for infinity, sum to infinity is a over 1 minus r. So here you are given your if the sum of to infinity, so this value for the sum to infinity is 60, substitute 60 for this sum of the to infinity is equal to a is what? 12. You are given that the first term is 12 over 1 minus, you don't know the common ratio. So That means when you now cross multiply, 60 into bracket 1 minus r is equal to 12. So open the bracket, 60 times 1 is 60, minus 60 times r is 60, r is equal to 12. So you are now going to bring this plus 60 to this side, we now turn to minus 60. So minus 60r is equal to 12 minus 60 will give us minus 48. So divide both sides by minus 60. So that means your r will be equal to what? So that means how many 12 and 48? How many 12 and 48? We have 4. How many 12 and 60? We have 5. So that means the value for your r is 4 over 5. Then the question says that find the second term. If the first term is 12, multiply the second term by 4 over 5, which will give us 48 over 5. This one to decimal and give us 9.6. 9.6. So for the work practice, calculate the sum of the following GPs. A, 1 plus 3 plus 9 plus 27 plus ... plus 729. B, 3 minus 5 plus 7 plus 75 plus minus ... as far as the seventh term. Then C, 1 over 2 plus 1 over 4 plus 1 over 8 plus ... plus 1 over 10 1024. Then D, 1 plus 0.2 plus 0.04 plus ... as far as the fifth term. Number 2, a GP has 8 terms. If the first and last terms are 0.3 and 38.4, calculate the common ratio, the sum of the terms of the GP. Number 3, if 3 minus x plus 6 plus 7 minus 5x is a geometric series, find two possible values for a, x, b, common ratio, c, find the values of the GP. Number 4, find the sum to infinity of the GP, 1 plus 0.2 plus 0.04. The sum to infinity of a geometric series is 100. Find its first term if its common ratio is 1 over 2. If the common ratio is 1 over 2. Number 6, the first term of a GP is 48. Find the common ratio between its terms if its sum of infinity is... if the sum to infinity is 64. The first term of a GP is 48. Find the common ratio between its terms if its sum to infinity is 64.